think there's a few people still coming in, so I'll give people a couple of minutes and then go ahead and start with the first presentation. And for my talk, I'm mostly talking about globodera pallida. That's the organism that I work on. But I do want to give a little bit of an overview of the situation in the United States and some of the regulatory aspects and how fields are regulated and how they come out of regulation. The progress we've made in the United States to eradicate potato cyst nematodes, and that's been the goal for the United States, is to eradicate. And so I'll give an update on where we are with that. Okay, it looks like we're ready to start. Welcome everyone to our second symposium of the ONTAD meeting. I'm Louise Marie Dandran from the University of Idaho in the United States, and I work primarily on globodera pallida, but I'll be covering both Rostokiensis and pallida in the U.S. today. As everyone knows, there's two potato cyst nematode species, Globodera rostokiensis and Globodera pallida. Let me see if I can figure out where the pointer is. Rostokiensis regulated by 119 countries and found in 71 countries worldwide, whereas Globodera pallida is regulated by 80 countries and found in 55 countries. So both nematodes have a lot of regulatory significance for potato growing countries in the world. So global importance, as Javier Franco mentioned this morning, it did originate in the Andes in this area, Peru, Bolivia, Chile. I think one of the main problems is its ability to survive for 30 or more years in the soil. I've heard reports of even 40 years these nematodes are able to survive that long in a soil without its host. So actually the first time I was in the Andes, I actually gained a lot of respect for globodera and its ability to survive in very xeric, very inhospitable environments. It is highly likely to be transported internationally, and we can all recognize how small the cysts are and how they do cling to soil. It's very easy to transport a cyst along with potato tubers, and that's pretty much how it's been transported throughout the world. As I've already mentioned, it's regularly passed in most countries of the world. So now just to talk about, do I have I'm sorry, I have a, do you see the map that's up here? Oh, well, not. Never mind. I can't see it anyway, so I don't know if anyone can. But there's a map of the United States just to show where the nematodes are. Globodera rostokiensis is found only in New York State, which is on the eastern part of northeastern part of the United States. And if you were to see the map, it would be just about here. And whereas Globodera pallida is found only in Idaho, which is in the western United States, and it's separated by about 8,000 kilometers. So very, very different areas. Idaho, of course, is the state where most potatoes are grown in the United States. We produce about half of the potatoes that are grown in the U.S. and Idaho. So this was a very important find for the state. It was found in 2006 in Idaho, whereas Globodera rostokiensis has been in New York since 1941. So it's been there for quite a long time. It's believed to have come in from Europe, probably from World War I, when military equipment was brought back to the country. It's believed that some soil was clinging to some of the military equipment and deposited Long Island, and that's how potato cyst nematode came to the U.S. As I've already mentioned, many countries regulate both nematodes. Both of them are contained in the U.S. I think certainly the success of the Globodera rostokiensis, the Golden Nematode Program, is that it is found only in the state of New York. It has not spread throughout other potato growing areas in the United States. This in Idaho since 2006 has been contained to a very small region. I have a map, so I'll show a little bit later. There's about 5,945 acres are infested in 8 counties in New York with Globodera rostokiensis. That represents about 20%, 25% of the land that is in potato production in New York. So it's a fairly significant amount of land that is infested with golden nematode in New York. In Idaho, on the other hand, we have about 3,047 infested acres, and that represents only 1% of the land. So total acreage in Idaho potato production is about 300,000 acres per year. So there's much smaller infestation in Idaho than in New York. The other really important part is that since that golden nematode has been in New York since 1941, there's been time to develop resistance. And that is what is being used currently to manage the golden nematode problem in New York. So there's about 43 varieties with resistance available to New York growers and other growers in the United States. Whereas for globodera pallida, we don't have resistance in any other type of potatoes that we grow in the Northwest, which is the long rusted type potato for dehydrated processing or for French fries. So now I just want to quickly go over an experiment that one of my grad students did. We were interested to show that the Idaho population was indeed had an impact on potato. And so he varied the rate of infestation from 0 to 80 eggs per gram of soil. And of course, globodera pallida behaves from Idaho behaves like it does everywhere else in the world. It's extremely damaging to potato. He did model the impact of globodera pallida on yield and found with a DSAT model that at 80 eggs per gram of soil, there was a reduction, 87% reduction in potato tuber yield. So that is a predicted damage based on the DSAT model at this rate. So extremely damaging. And that is one of the reasons why the United States has taken this so seriously and put a containment and eradication program in place. So what are the goals for the GN and PCN programs? I think they're very similar. First, prevent the spread. Second, find out where it is. Third, contain and eradicate the current infestation. And then the last goal is to restore lost foreign markets, and that's been a very important one. It's taken the state of Idaho quite a long time to achieve that. I think Japan just recently reopened the market to Idaho potatoes within the past year or so. It took about 11 years to get there, but we've been able to reopen all markets. So as I've already mentioned, globodera pallida is found only in Idaho in 2 counties, Bingham and Farmville. It's a fairly very localized infestation in 2 counties in about a 16-kilometer radius. I live up in Latah County up here. That is about a 12-hour drive to get to the field plots. So it's quite a commitment in time to get there. This is where the University of Idaho is. Okay, so just to go over again what USDA APHIS does for detection and also to contain the nematode and eradicate. The first step is to survey so that they can delimit where is the nematode found, and they have a very intensive program to survey fields. Of course, they contain, and this is done through different measures, and one of them is any equipment that goes into an infested field has to be sanitized, steam sanitized when it comes out. And this is something that APHIS has undertaken. They bring large equipment, put it on a cement slab, cover it with tarps, and have a steam generator that pushes steam into underneath the tarp until a certain temperature is reached for a certain time. And their last goal is to eradicate. This has been done through primarily soil fumigation. Again, remember, there is no resistance available in the types of potato that we grow in the Northwest. So this is, again, my grad student, Jean-Bertrand Contina, who's done some spatial analysis of the region to determine about where is it found and what is the infestation foci. And here, he's pretty much shown that there is one field that was the infestation foci, and from there, the nematode spread throughout the region with various levels of density found within about a 16-kilometer radius. So highly aggregated population, most likely one introduction. So I want to go over the process. Once PCN or pale cyst nematode is found in a field, it is automatically regulated by USDA and APHIS, as well as the Idaho State Department of Agriculture. Now, to get a field to be deregulated, there's certain steps that need to be taken. And so I'm kind of just going over these steps here. The first step is to look at egg viability. Once eggs are no longer viable, so they will sample yearly until there are no viable eggs found. I think this has taken about 7 to 8 years to get to the stage. So fumigation once or twice a year to get to a stage in a field where egg viability had dropped down to 0. Once that's happened, then they send cysts up to the University of Idaho, where we do a greenhouse potato bioassay. And here we send a sample back down to APHIS, and they look for any signs of reproduction. So they're looking for cysts. After 3 rounds of finding no reproduction from these samples, then a grower can actually go back. Is this still working? Yes, it is. A grower can then go back into potato production, but they're still not quite out of the regulatory program. For them to be completely out of the regulatory program, they have to do an in-field bioassay, which is basically planting a susceptible potato for 3 times. So whether they do it consecutively or in rotation, it doesn't matter to APHIS. After each time, APHIS goes in and samples again to make sure that there's no reproduction has occurred, there are no viable eggs. So currently we have 22 fields out of 27 infested fields. That's about 867 hectares where we're not seeing any viable eggs by Moldola's testing. Of those 22 fields, we've seen 13 fields that passed the greenhouse bioassay. So quite a number of fields can now go back into potato production if a grower chooses to do so. But many are not. They just don't want to put potato back into their land. One grower has chosen to put one of his fields back into potato production. He's gone through 1 round of the in-field bioassay. So that's where we are in terms of deregulated fields in Idaho. So we've made a lot of progress, still some ways to go. So now I'm going to just start talking a little bit more about what we do as researchers. And we have quite a large team of people working on developing different measures to control this nematode. We work with development resistance. We've worked extensively with this trap crop, lychee tomato, Solanum cisimbrifolium, studying to understand a little bit better how PCN actually defends itself, look at various plant defense in Solanum cisimbrifolium, which is not a host to this nematode. We use biofumigants as well, and there we've been very successful in developing some extracts that are highly effective against the nematode. And we're also working on helping APHIS better detect globodera pallida, whether or not it's viable. But I'm only going to talk about 2 of those rather than covering everything we do. I'm just going to talk about resistance development and where we are with that, and then a few slides about what we've discovered with the trap crop Solanum cisimbrifolium. So first of all, this is a slide that John picked up from the Scottish government sent my way, and I really appreciate it. But it just shows the value of resistance over time. And this is globodera rostokiensis populations are being used and controlled by resistant varieties in the UK. On the other hand, resistance for globodera pallida is not quite as readily available, and it's not used quite as much. And as globodera rostokiensis has dropped off, pallida populations have increased over time. So where are we in terms of developing resistance in the United States? I will tell you, a couple of years ago, I would have said there isn't any. And we're still pretty much, there isn't any, but we've made quite a bit of progress. Breeders have been incredible. They've worked very hard, and we're seeing one accession, which is, there's still quite a bit of work, but which is highly resistant. So 1 here, a resistance score means it denotes it's very susceptible, whereas an 8 or 10, 9 or 10, highly resistant. And this is Desiree, which is pretty much what we use as a control to show a very susceptible potato, and Innovator, which comes from Europe, which is highly resistant to globodera pallida. So we are starting to see some of the rusted types, but we have quite a long ways to go. So now I'm going to turn our attention to the use of the track crop lychee tomato, which is also known as Solanum cisimbrifolia. And this plant originated in the same area as globodera potato nematodes. It is from the Andes Mountains. It's actually, it's an impressive plant, is probably a kind of way to say this. Beautiful flower, I think, but it's incredibly spiny. So it does belong to the spiny Solanum group. It is distantly related to potato. But I think in Europe it's been demonstrated that this plant causes hatch-good nematode and can decrease populations at levels of both globodera rostokensis as well as globodera pallida. So we've done some work on this and done some field work where we either have a bare soil treatment or plant with Solanum cisimbrifolia in 5-gallon buckets, so small white buckets, or else in stock tanks, which are about 150 gallons. And then at the end of the season, we either look at egg counts, how many eggs are left in those cysts, as well as viability of those eggs that are left. And then to simulate a rotation, I bring these back up to Moscow because I'm not allowed to plant potato in the field. I bring these back up to the campus up in Moscow, and under greenhouse conditions, I'll plant potato on top and look at the impact on reproduction from having planted lychee tomato or Solanum cisimbrifolia. So here the soil has been infested or not with globodera pallida, and then we either plant lychee tomato or not. So it's a comparison is a bare soil or lychee tomato treatment in a rotation type of system. So our results have been very, very encouraging. Basically, we find a fairly, it's a reproduction factor of 4.2. So every time we plant potato, we just have bare soil and then plant potato, we have about a multiplication rate of 4 times greater. When we follow lychee tomato, when we plant lychee tomato and follow with potato, our reproduction rate has dropped significantly. Here, you can't see that number, but it is 0.02. So we see a huge decrease in the population of nematode on potato after planting lychee tomato. So very interesting for growers as a potential tool to control the nematode. So in this experiment, we did a similar type of thing. This is done in the greenhouse, so not in the field. There's no portion of it where we've done this in the field. But what I wanted to do is compare a resistant potato to the track crop Solanum cisimbrifolia. So here's a susceptible, here's a resistant, here's a track crop, and here's the bare soil. Here's the first cycle where we're finding 357 cysts per root ball on a susceptible, 3 on innovator, so behave exactly like we thought. And of course, Solanum cisimbrifolia is not a host, so we didn't find any cysts off of Solanum cisimbrifolia. Waited, put everything in a cold room for 8 weeks, came back and planted a susceptible potato on top of everything. And this is where, again, we see this trap crop being so incredibly effective. So here's a sequence of the susceptible followed by susceptible, 622, huge increase in the nematode. Here's innovator first, and then followed by a susceptible. Oh, we're getting quite a bit of reproduction in that particular sequence. But when we use this track crop and then plant the susceptible, we barely get any reproduction. And what I'm not showing here is that these cysts typically have hardly any eggs, which I find really unusual. But it is found this every time I do this type of experiment, that there's not only a reduction in the number of cysts, but in the fecundity of the female as well. So quite interesting. And this holds true for whatever density we put out there, either 5 eggs or 20 eggs per gram of soil. So real quickly, I just want to wrap this up and thank all the collaborators that work on all these various projects, and my own research team, as well as our funding agencies. And this is the award that brought us all here today, the globodera Alliance project. Are there any questions?
Deregulated. How GP going to sample consider the nematode, how you can find the nematode in the soil profile and consider which you can have 30 to 40 years of viability. I know you did the test for viability, but the most important factor, my question is how deep you do the sample.
The sampling is from APHIS is usually pretty much superficial, so it's right on the soil surface. However, APHIS has also conducted some assays at depth, at various depths, and collected retrieved nematodes. And I think they found it down to about, not quite 1 meter, but down pretty low. Of course, this nematode is tops, 6 inches is how many? 12 centimeters. So about 10 to 12 centimeters is about the depth of where you find the most cysts, from the top down to 12 centimeters. APHIS has also done some bioassays on cysts collected at these different depths. And I'm thinking that some of them at the lower depths were viable. But we also have to remember that potato roots, for the most part, don't go down to depth very much. And I don't know after methyl bromide if there's ever been, plants that have put into my bioassay to determine what the impact of fumigation is at depth. But I would assume there's some kill, probably not everything. I'm not sure. Yep. Yes. Any other questions? Yes.
So,
do you want to use the microphone?
No, I'm fine. I'm loud anyway. So, no, the question was on the last slide, you basically made extracts of that lychee tomato, right?
Yes, so I'm making a water extract, so a water extract of plant tissue, and then freeze drying it, and then reconstituting in water.
Okay.
So it's not the diffusive, it's not the root diffusive.
Okay. I was wondering if you try to expose, lab level, just try to expose the eggs straight to that and see how they react to the different extract.
Yeah, we're working on it. This is just the very first experiment that we did. So that is definitely one of our challenges right now. How do we work with a nematode, a plant that actually will cause a nematode to hatch and show inhibitory impact? It's a challenge.
But you're working towards having eventually an extract, a product molecule?
Yes, that would be, she's asking, are we working to find to purify whatever might be inhibitory in lychee tomato? Yes, that's what we're trying to identify. If, first of all, is there something inhibiting the nematode, and if there is, then we find what that compound is. Yes.
So any ideas at this point, working backwards as to when the introduction occurred? And then the second part to that question would be, if the nematodes are really in the surface, and there's the possibility of wind erosion.
Oh, I'm not saying, so I'm just saying that APHIS samples at the surface. That's how they do it. So to answer your first question, is there any way to trace back when it started? Beyond me. I just have not done that, and I don't know if anybody else has taken that challenge. I would say just by looking at the spread and the numbers of nematodes, I don't know, 40 years, 20 years, it's hard to tell.
So that's where I was going to follow up with. Do you think it's possible that there's infestation percolating other places that will show up in 40 years?
I think it's possible, like within that region, what APHIS is seeing is when they sample and retrieve soil samples, whenever there is a new detection, it's very low. So it's like in 100 acres, 1 cyst, 2 cysts. So they are still finding new detections. I think it's been over a year now that they have not found anything new. But any new introduction is most likely related to that foci infestation that I showed you. I don't know, I can't project the future either. I don't have foresight. But that's what we're currently dealing with, and that's what we're seeing.
Yeah, so of course our history in Wisconsin with the potato rot nematode, Didylincus destructor, very different nematode. But
kept popping up.
quarantine, well, it took 30 years between the last detection and then all of a sudden it
The one that
came up again.
it's very feasible that it can come do that. We just don't know. So did everybody hear Ann's comment? Yes. Any other questions? Yes.
How much what is the amount of soil that you analyze for hectare? Because if you analyze more soil, you will detect more, isn't it?
Yes, I think that at the rate of soil that's being used, it's about 99.9%. Assured.
So how many kilos you analyze?
So in terms of, I think it's something like probably 100 kilograms per acre of soil. I mean, it is extensive. It's not just a little sample. It's not just, 100 cc's. It is a very large amount of soil that they run through. I think that Inga figured out the number of elephants, is that what it was?
Asian elephants.
Asian elephants. It's 226 Asian elephants. That is the equivalent of soil that's been sampled since the inception of this program. So 3 million pounds of soil have been sampled in this area. So a huge amount. So I don't remember quite the numbers exactly, but approximately, yes.